Okay, so good evening, everybody. All right, good evening. Okay, so hope we're good. Hope we're good. Hope we're good. All right, so in our last class, we wrote some tests. Okay, let me bring this right down a little so you can see. Okay, so in our last class, we wrote some tests and we tested our Fund contracts. Okay, so we ran some tests to test our Fund contracts. We we did some refactoring. Okay, and we we learned how to declare our numbers very well rather than using magic numbers. Okay, and so instead of having numbers here, we just declare it up and then we use it. Okay, we declare it as constant and then we use it. Okay, so like I said in our previous class that when you use constants like this, they tend to reduce gas. Okay, let me open main contract. Okay, they tend to reduce gas and it's gas efficient. I can remember in one of our classes I said that the most important thing is to write very a very good code. All right, gas optimization is secondary. Your smart contract is primary. Your writing of smart contract, your ability to write a very good and readable smart contract is more prioritized, should be more prioritized than the gas um, optimization. Okay, so after writing a very good code, tested it to be working, then you can now start optimizing your gas. Reason because it is it's better to have a contract that is working very well, that is secure, that is not gas um, efficient, like optimized, than having a gas optimized contract that is not that is vulnerable to attack. Okay, so we'll put that in the back of our mind. All right, and also we should also put some best practices in mind. All right, to see that we turned our storage variables to x. Okay, we added s to our storage variable initially. You see that we have immutable here and we added I to our mutable um, um, variable. All right, we added s to our storage variables so that we know, okay, this one is storage variables and this one is immutable variables and all that and all that and all that. Okay, so that's one thing about storage variables and rightly declaring our variables are variable types. Okay, so we might not be able to go into that deeply, but I want to mention that when you store your functions on your state variables, when you store your functions outside, you store your variables outside a function like your state variables, global your state variables. Okay, so they are stored in storage. You use a storage, you understand. Now if storage variables cost more gas than other types of variables, and okay, we have storage variables, we have the memory, we have the storage, we have the memory. Okay, so memory is less costly than storage. So storage is costly when it comes to gas usage than memory, right? Now, when you use this keyword constant, all right, when you use constant, let me show us here. When you use this word constant, okay, these variables are not stored in storage. All right, these variables are not stored in storage. They are stored in the contract as bit codes, as bit codes. You understand? So they don't have they don't have any permanent storage here. Okay, they don't have any permanent storage. They are only called upon when needed. They are stored in the contract. They are not stored in a special storage environment at all. All right. Over time, you get to understand. I just want to mention it for so we know and why we are optimizing our code in the first place. Okay. So that's it. All right. So today I said that we are going to be running a test. Okay. So we we did a test. We run a test for funding. We run a test to check if our requirement is working. We run a test to check if our contract is fundable. We run a test to check if the funder is added to the array. We run a test to check if for multiple transactions. Okay, and saw the output. All right. So today we are going to be writing a test for withdraw. All right. First of all, let us um, write a test. Okay. So um, write function. Okay. We are going to test now. If we come to our withdraw, which is this. All right. This is our withdraw. Yes. This is our withdraw. All right, so if you come to our withdraw, we made a clause. We had a clause here and said that only owner of the contract can withdraw from this contract. All right, only owner of the contract can withdraw from this contract. Okay, so and we wrote a modifier. All right, these are we did it. We wrote a modifier. Okay, we wrote a requirement to say that owner should be message or sender, the initiator of the contract, okay, the creator of the contract. All right. And so we said that for anybody to withdraw the money that has been sent, it has to be the owner. Okay. So we want to test that. We want to test if only owner can actually withdraw um, from our contract. Remember, we said first thing we tested here was enough if, okay, the requirement, our error. All right, so we are going to run a test for if only owner can withdraw. So I'm going to call it test only owner can withdraw. All right, so this is going to be like this and public. Okay, so now we are going to run a prank. Okay, so we're going to run a prank and we're going to assume owner. All right, we're going to run a prank and we're going to assume owner. So we're going to say vm dot prank user. I'm going to say fund for needed fund value. All right, and so you say, okay, so why are we writing this? I thought we are we are checking for withdrawal. So why are we adding funds? We are adding funds because you cannot withdraw what have not been added. So we have to assume a user have funded our contract, and then we now withdraw. Can see if the user can withdraw. If the user can withdraw. Now we are going to be using the expect revert to test this error. So like I said in our last class when we were talking about expect revert, that expect revert work for only errors. So if 1 plus 1 is 2, then expect revert will pass everything except 2, okay, to test that the error is working. Okay, so we are going to be so I'm going to do vm prank again, vm.prank. Then we are going to be calling user. Now we say that whenever we use prank, we are saying that the next code that comes after is going to be done by the guy in the bracket. You understand? So this vm prank user, they're saying that the next line that comes after vm prank user, that means this guy, this fund, this funding, the funding of the contract is going to be done by the user. All right. Now we're going to be doing another one whereby this user now is going to be withdrawing. Okay. So we're going to say vm dot expect reverse. Okay, and then I'm going to fund me dot withdraw. All right. So okay, so let's save this, and so let's run a test. Okay, so let's run a test. Let's run this test if it's going to work. Okay, so sorry about that. Okay, so let's have it. So what am I doing? Was that what have I typed for this match this row? Okay. Okay, so let's wait for our test results. All right, so our test ran successfully, and then that means it failed. The user cannot withdraw from our our contract. Okay, so just realize that user cannot withdraw from a contract. All right, now there's something you observe something here, that for us to um for us to use funded, for us to fund our contract, we see that we have to write a prank fund contract, and then we have to write another prank to withdraw. We have to write prank contract and another prank to withdraw. Now remember what we did here when it comes to withdraw. You see that when we wanted to set a particular function, something that can be reusable, here is my guy. Okay, so something that can be reusable, we wrote what they called modifier. We wrote a modifier. So what this modifier did was that this modifier stands as a requirement, meaning that when we call um, add only owner, this modifier, when we add only owner to our withdraw, it automatically runs this requirement before executing this code. Okay, so it runs the requirement, the modifier, sorry, it runs the modifier, yes, which is also the requirement in the modifier, before running this function. Okay, so that is what this modifier does. So if we, since we are working with withdraw, that means for every test we are going to be working, there have to be a user funding our contract before we can withdraw. You understand? So for us to withdraw, there have to be a funder. So that means for every time we are going to be writing our withdraw function, we are going to be writing a test for withdraw. We are always going to be writing this line of code. Okay. So for us not to be writing this line of code always, all right. So we can just write a modifier so that we'll just call it here, just add it to this place, and it will fund our contract before um withdrawing. Okay, so let's see it in action. Okay, so let's see it in action. All right, so we are going to write a modifier. Okay, so I'm going to call it funded. Okay, so we're going just to copy this line of code and paste it here. Alright, trying to arrange my code. Okay, so having done that, we can come and add our guy here. Okay, so we are telling this guy that this guy is going to run first before any other code. Okay, so that's what we are saying, that this guy is going to run first before any other code. So we can come here and remove this guy. I'll come and remove this guy and just add funded here. Okay, so and this one flies as well. So if I press Ctrl S and then I run this code again. Okay, so let's see how it goes. Okay. Oh, sorry, sorry. I did not spell my modifier very well. Sorry. My bad. Okay, so let's run it again. Okay, so here it goes, and boom, it passed. All right, so for every of our tests we are going to be writing, we won't need to write any other prank for users anymore. We just use our modifier. Let me take it from here to here so that we can have all our all our codes organized. Okay, so save it, and okay, so all right, um okay, we have written a function to check for withdrawal. All right, if a user um can can withdraw somebody that is not um the owner. If the person can withdraw, I'll just realize that that error stands, only owner can withdraw. Okay, so let's test for single funder. All right, let's test for single funder. Remember, we tested for single funder. Yeah, all right, we tested for single funder and we tested for multiple funders. Now we're going to test for withdrawal for single funders and withdrawal for multiple funders. Okay, so let's balance the equator. All right, let's find the equation. Sorry, don't mind. Let's balance the equation. All right, so we're going to write a function. I'm writing something else today. That's my function. Not looking like function. Okay, so function um test withdraw with single funder. All right, so make it public. Okay, so remember I said that every time we are going to be testing our withdrawal, we're going to be added our funded, so that we don't have to write this guy again. Okay, all right, so that we don't have to write that guy again. Okay, so all right, now this is where kind of gets a little bit interesting. All right, now um there is a methodology, all right, I learned from um this guy Patrick. Okay, so on the group I'm going to share you his Twitter handle, so you to follow him. All right, is one mentor that every Solidity beginner, Solidity developer should follow. All right, so according to Patrick, okay, said whenever he's writing his tests, and which I follow, he uses three arrangements. He uses arrange, acts, and he uses asserts. Okay, so arrange, act, and assert. Arrange is you you write the code for the preparation for the stuff, like added the balance, you check the balance, you add funds to the balance, you add funds, you check the balance, you get everything ready, and then you act, you fund the contract, and then you withdraw. All right, you do the action, you withdraw. Since you are testing withdrawal, you withdraw. You are testing funding, you fund. You are testing withdrawal, you withdraw. And then the assert is to write a test to check if this is equal to this. All right, so let's put that into perspective. Let's put that into action. All right, so we are going to arrange. So what are we arranging? All right, so if you come to a fund me contract, understand that whenever they fund, remember when we were testing it in our um, remits.id, when we fund our contract, okay, when a user sends money to our contract, we can actually go to our contract and see that money has been funded in our contract. That means we have a balance. We have we have a balance. We have a wallet. We have a balance. We have where the money is. Okay. So for us to actually know the balance, we have to say that our starting balance, just like our starting balance, we get our starting balance, and when without funding, and our balance after funding. Okay, so I'm going to be using 256. Just start, yeah, starts on a balance is equal to fund me the get owner. All right, I will just pick the suggestion. Okay, and then the balance to fetch the balance of the wallet. Okay, so we'll do that again. You 256. All right, to create another one, is equal to address. So we're taking address on me. All right. The balance. Okay. So that's our setup. Okay. So we're going to act. So in our action movie, okay, we say fund me that gets owner. All right. Now, what we are trying to do here is that we want to act like the owner. All right. You're not acting like the user. We are acting like the owner. Okay. So, and we are getting this owner from the get owner function. All right. You come to this place. All right. We put a function here to return the owner, get owner. Remember, let me tell you how it works. Remember, we created owner here and we said this owner is the message of sender. The address, this message of sender is the address of the initiator of this contract. Okay, and then this is where we got returned the message of sender, the owner. Okay, sorry, driving at the wrong one. Okay, let me. All right, look at it. Yeah, yeah. Thank you. Now this is where we actually get the owner, the address. All right. So when you return I owner, stand you are returning the address of this guy here. Remember, this guy is an address. You are returning the address here. So when we say that we are pranking the owner, we are pranking the fund me owner, which is the address that we returned there. All right. Remember that this contract can only be withdrawn. The funds here can only be withdrawn by the owner of the contract. Okay, and then we'll say dot balance. Oh, sorry, say dot balance. Okay, and then we withdraw. Let me take this guy. Withdraw. Right. Okay, remember that this guy is a function. All right. So surely put a bracket here. Okay, and then sorry, this guy is supposed to be to F. All right. Okay, so having done that, we can now assert. So we have withdrawn from our wallet. So we can now say uint 256. I'm going to say ending owner balance is equal to fund me to this guy. All right, so I just copy this guy and I don't want to. Right, balance. Okay, so we can write more and say that in 256, if you say just unit, still the same thing, but want to be explicit. Okay, the same thing. All right, and then we can now assert that ending balance, okay, is equal to 0. That's after we withdraw. So after withdrawing everything, ending balance is equal to 0. And then also assert that our starting balance plus our starting owner balance is equals to ending owner balance. Okay, so starting owner balance plus starting funding balance plus starting owner balance is equal to ending owner balance. All right, and we cover that. Okay, so let's save this. All right, before we run a test, let me go through it one more time so we know what we're doing. Okay, so I said that starting from here, we created this function to test our withdrawal from one user. All right, so we first of all we fetch the balance of the owner. All right, the our contract balance, and then we fetched the balance of the user. All right, so there are two balance we fetched: the balance of the owner and the balance of the user. Okay, and then we funded the user. Remember, remember, when we say the balance of the user, we when you come to this place, all right, so when you come to this place, you realize that the balance of the user is 10 ether. All right, so we are fetching 10 ether. Okay, we are fetching 10 ether, which is the balance of the user. And then when you fund the contract, okay, with this, all right, 0.5 ether. All right, so we are saying that we are fetching the user's balance, and we're fetching um the owner's balance, which is the contract that we deployed to be receiving this money. Okay, so we have to know the state of the balance first. Okay, so after that we withdrew. All right, after fetching the balance we withdrew. Okay, now we saved this balance, the balance of our user in start fund balance, and we saved the balance of the owner with start owner balance. Okay, and then we withdraw. Now remember that there is no place for funding here because we've already called our modifier. So here at this particular point our contract has already been funded. Okay, so we withdrew. After withdrawing, we tested we tested if the ending fund me balance is zero. Okay, so after you withdraw, okay, after sending, all right, after sending, if the contract after withdrawing, if the contract balance is zero, okay, if the contract balance is zero, so we say that start fund me balance and start owner balance should be equal to ending owner balance. All right, how much is sent in, how much is withdrawn, okay, and it should be equal to ending owner balance. You understand? So that's what we did here, and then we are certain that the end owner balance, the ending fund me balance is equal to zero. All right, remember that our owner balance is the contract that is withdrawn. Our fund me balance is our contract balance. Okay, so when you withdraw, you understand, when you withdraw, after withdrawing owner balance, before withdrawing fund me balance, so this plus this should equal to this. All right, if you have $5 inside the wallet and withdraw $5 inside the wallet, all right, you do $5. Okay, if you don't have $5 inside the wallet, if you have $0 inside the wallet and you added $5 inside the wallet, if you add 5 plus 0, it's going to give you um 5. All right, so that's how the mathematics work. Okay, so if you test this, okay, let's just see how our test is going. Let's wait for our test results. Network, so that's why our test is taking a little bit time. All right, so our test ran successfully, so that means we can fund our contract, can withdraw our money from a single deposit. Okay, so let's test for multiple deposits. Okay, so let's test for multiple deposits. All right, so we just say function test withdraw multiple funders. Okay, so let's test for multiple funders, right? Excuse me. Okay, so let's test for multiple funders. Sorry, I was trying to adjust. Okay, so for us to test for multiple funders, we use 256. Okay, and then say number of funders. Now we are trying to create the numbers of funders who want to fund. All right. Remember when we create multiple funders? Yeah, I told you in our last class that there are better ways to create this. All right. If we want to create um 20 funders here, we have to duplicate this guy into 20 places. All right. So here we want to fund it with we want to fund it with 10 funders, or want to fund it with 12 funders, or want to fund it with 13 funders. Okay. So that means we have to come here and run it in 20, or probably come and change our modifier. All right, or write a different modifier for it, or yes, write a different. You can come and do it like this. Copy. We can do it like this. Okay, and then in the place of this font, you can come and okay, call this one funded M from post Ctrl Z. So copy this guy, paste it, 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 paste it. All right, how many do we have here? One, two, three, four, five, six, seven. All right. Okay, so we can do this if we want to. Um, let's make it 10. Right, 7, 8, 9, 10. Okay, so we can do this approach 10. All right. If we want to create 20 multiple folders, you can copy and create multiple folders like this. Ctrl. Now you see how tedious and how long this thing is looking already. So if you want to test for 50 folders, if you want to test for 100 folders, so you have 5, like this is 20 already, you multiply it times 5 and all that. It's going to make your code unnecessarily long. Okay, it's going to make your code unnecessarily long. All right, so how do we do it? What are the shortcuts we can do to to multiply as many um founders as possible? Okay, so we are going to be using what you know already, and that's going to be loop. Okay, so that's going to be loop. All right, we're going to be looping through. All right, and then creating some um I'm going to be creating some wallets. Okay, we're going to be creating these wallets, and then we're going to be funding the wallets. All right, we're going to be creating the wallets, and we're going to be funding the wallets. Okay, so let's get right into it. All right, so what we're going to do is that here's my okay, so we're going to say that numbers of funders equals to 12. Okay, let's make it 13. Right. Okay, let's make it 15, a random figure, a round figure, sorry. Okay, so I'm going to say in 256, All right. Since we are going to write in a loop, so it's going to start from somewhere. Okay, so it's going to start from somewhere. So we want our loop to start from somewhere. Okay, we want our loop to start from somewhere. All right, so we are going to be declaring this guy one, 0. All right, and then we can say that we write our loop and say for okay, I do remember this where our index is. Okay, all right, so we'll say that I is going to be less than the length of our array. All right, so I'm going to say I is going to be less than number of founders. All right, so I'm going to say that I is going to be less than number of founders because that's the number of address we want to generate. Okay, and then we could say that I plus plus. All right, okay, so um and then we okay, so this something, if we go on with this, all right, we'll go on with this. Now you got to understand that this loop is going to be working with addresses. All right, this loop is going to be working with addresses, and according to the latest version of Solidity, if you use you in 256 for addresses, it's not going to work. All right, the integer class that is going to work for that is going to be working for addresses is uint 160. The reason that the bit size of address is equal to uint 160. Uint 160 and the address bit size are the same. All right, they are the same. That's why it they want us to use uint 160 for addresses. All right, whenever you are calling addresses. Okay, this one flies. All right, but if we are using this for an address, we can't use uint 256. All right, use uint 160. Okay, so I'm going to change this guy to uint 160 so that we don't have an error. Okay, so let's change this to 160. Okay, so we don't run into calamity. All right, so our wallet. All right, we're supposed to fund our wallet. Okay, so the cheat code for funding wallets. All right, cheat code for like we used in funding our user here. All right, okay, so
The same way we use the D here. So that's how we're supposed to use our D here. So when we generate these addresses, we're supposed to add funds to these different addresses that we've generated. Okay. Now we are supposed to use um, deal and then use address. Okay, the same way like I showed you, the same way we did it. But we are going to be using another cheat code called OAS. Is it OAS? Let me write it so I believe you can pronounce it better. OS, 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 OS. All right. So what does OS does? What does OS do? OS combine both the deal and the make address. All right. Remember this guy, deal and make address here. All right. So what does OS do is that it generates the address and it fonts it. Okay. That's what this um, cheat code does. It generates the address, which is this make address, and it fonts it. Okay, so it generates what we are going to be doing is that we're going to be generating 15 addresses, and we're going to be funding these 15 addresses. So when we make payments as the user, the 15 addresses are going to be making payments. Okay, so that's what we are going to be doing right now. So we are going to say us. Am I? Yeah, us. Yeah, us. Address. Okay, so what address are we funding? We are funding this address, funder's address. Okay, so it's going to be I, right? And then send by. Okay, so sorry. All right, and then I'm going to say fund me, dot fund. Now this call it the fund function. Okay, and all right, it's supposed to be like this. Okay, so our value and then how much we are sending. So okay, so let's do what's right. So we don't send empty transaction. Okay, so that's it. All right, so what we've successfully done is that we ran through a loop to generate for us. Created a loop to generate for us 15 addresses. Okay, so we said that this guy is going to start with I. All right, so we're going to change this guy to all right. So we are going to change this to one. Sorry, I keep having network bridges. Sorry. All right, we're going to change this to one. Reason because most times when you start your loop with zero, it fails. All right, so we start with one in case you want to because any error at all. All right, so we're starting with one and we've generated 15 addresses well funded. All right. So let us work with these addresses that we funded. Okay. Let's work with these addresses that we funded. So say that you're in 256, we create a new one and say starting owner value, the same thing that we did before. Okay. So um, this guy here. All right. We just copy this guy. All right. But won't be copying. So let us type it ourselves. They said repetition is the mother of learning. Okay. So let us type it ourselves because repetition is the mother of learning. All right. Okay. So we say that starting. Excuse me. Okay is equal to Foundry that gets owner. So we are getting this owner. All right, getting the balance like we did. Okay, so this is going to be you can remember what's this arrangement. All right, so okay, so let's continue, and then we have the units 256. So we have the starting funding. Okay, we have here starting funding balance is equal to address. It's the same thing we wrote earlier. Okay, so in brackets. Okay, so after the arrangement, all right, so all this falls under arrangement. Okay, so we can now act, we can now take action, so we can now act, we can now fund the contract. Now there is this. All right, there's this method of writing prank. Okay, excuse me, by want to withdraw, we can say vm.prank. Okay, vm.prank. Normally this is how we start, this is how we do it, right? vm.prank, and they will say user. Okay, now we don't want this, we want the user, the owner, to withdraw. Okay, we want the owner to withdraw, so we say the fund me dot get owner. All right, so this is what we want to prank. Okay, the get owner, but this time we want to use this method, the start prank and the stop prank. Okay, so we are going to say start prank. All right, and so whatever is within the start prank pm stop rank. Whatever is within the start rank and the stop rank is actually what is going to be working. All right. So from where the prank starts to where the prank stop, that's what is going to happen. After this stop, prank is not working again. Okay. So we are going to be withdrawing. All right. We're going to be withdrawing like the way we withdrew um in the single test. Okay, so withdraw. All right, so now let's our assert. So from here is our arrange. Sorry, not from here. From here is our arrange. Yes, our act. Okay. Next thing we are taking into consideration is our assert. So let's assert. All right, I'm going to assert that address of our Foundry, our contract, okay, so is equal to 0. Also, we are still going to assert that our starting plus our starting okay is equal to, you can say comma or you can just say equal to the address. All right. All right, so let's put this into test. Let's put this into test. What have I done so far? What jargon have I written? All right, let me go through it. Um, let's go through it one after the other. Okay, match found document and lookup. Okay, so all right, I think I have a typo error here. Okay, so I think this is where my error is stated. Okay, so let me look at it. All right, so let me look at it. I think we're having an argument that's not in lookup, sorry, so I think we misspelled something. Oh, right, so let me see, balance this, that, let me balance, say, let me balance, let me balance, okay, Okay, so let me fix my error. I'm coming. Sine balance is equal to this. Okay, sine balance is equal to that. For me, that's get balance. Um, okay, so let me run from stats. Let me see where I missed it. All right. Okay. So it said that I'm gonna look up. Okay. Start from need balance. Start from need balance. Start from need balance. Equals to address this and this. Okay, this equals to this. Okay, functional circle. Right. Let's right. Okay. So this is this. Just will be this. Let me ask that. All right. So let me look at it. Okay. So let me look at this guy. Let me look at this guy. All right. Let me look at this guy. And then look at this guy. Okay. So let me comment this guy out. Let me test if this guy is going to work. I'm coming. Let's. Okay. So let me run a test on this. I'll come back to that. Okay. So I'm going to run this and. All right. So let's see. All right. So our test passed. Okay. So our test passed. We didn't test this guy because I don't know where our error is coming from. I've looked at this guy again. Our loop is running very well. Our contrasts are funded, right? So what could be the matter? What could be the matter? Okay, so all right, so we're having an unexpected error. Okay, so I'll just comment this so that it doesn't obstruct us. We have limited time. We have to cover everything we need to cover. All right, so on your own, just run this guy, and it's going to work. Just run this guy. Okay, just run it, and if it spots the error, drop it in the comment section, or drop it in the group, or drop it in the group, or have it in your discussion, your group. Okay, and then that's it. All right, so let's go on, let's move 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 on. Okay, so finally we've run a test for withdraw multiple funders. We've run a test for single withdraw multiple funders. Okay, and then excuse me, run a test for single withdraw multiple funders. All right. Okay, so um so what next? What next? Let's run our coverage and see how far our test has gone. So if I click forge coverage, I think I've misspelled something again. Okay, okay. Alright, coming. Let me check where we're getting our errors from. Alright, so let's see. Function assert 56 memory less. Right. Okay. Alright, I'm coming. Let's fix this one after the other. Okay. So page number selection and argument to go. Okay, and then fetch test. Q. Okay, so oh sorry. Let me take this and point again. Fetch test, fetch coverage. All right, so you see that our our code has been optimized more than we had it before. All right, so you see that a lot of greens are here and not here rather than the red. Okay, our fund me contract is 100% tested. Okay, It's 100% tested. Our script 100%. The lines are script 100%. Our contract is 100%. The branches are 83% tested, and so on and so forth. Mock 50%, and our total is our contract is um 75% of our contract line is tested, testament says 60%. Okay, so we are a little bit above pass mark. Okay, this is going to be a pass mark. All right, so I'll give you as an assignment, see if you can optimize these contracts and see if you can boost this total coverage from 75 upward. Okay, so all right, so that's it. Now let's continue. You see that if we click on um, if we go to Forge snapshots, you're going to see the gas we are using. All right, you're going to see how much gas you are spending. You're going to see how much gas you are spending in running these transactions. Okay, you see that in this code or whatever testing, we don't put um, gas fee into consideration. All right, we don't put gas fee into consideration. What we are focused in doing is just the transaction. So while you are running your test in the local chain, all right, Anvil makes your gas fee, zeros your gas fee. All right, so you are paying zero gas fee. They don't put gas fee into consideration. They just focus on your transaction and not the transaction costs. Okay, so the local chain works without gas fee, but we have to know how much our gas fee, how much our contract is going to cost while running it. Okay, so that's where our snapshot comes in when we use our forge snapshots. Now you see that every of our tests comes with a comes with the gas price. And I see that when we run the snapshots, we have this gas snapshots file created here. So if I open it, you see that everything that we have here is here. All right, you see that this guy costs 100,000, 103,000. This guy costs 25,000, and so on and so forth and so forth and so forth. You get it? So this is how much our gas our contract, excuse me, this is how much our contract is costing. Now if you notice, you see that the contract that works with our storage variables cost more. Okay, the contract that works with our storage variables cost more. What do I mean? I mean that storage variables like coming. Okay, so these are storage variables. The ones with the S that were declared here, all right? These guys, funders, these are storage variables. All right, these are storage variables. Funders, uh, address to amount spent, price feed. These are storage variables. Okay, these are the storage variables that cost us most gas fee. All right. Whenever we call in funders function, funders variable, we eat more gas. Okay, so when we come to testing, you see that we are whenever we are using them, whatever um, of the tests that we are using them, we spend more gas fee. Like I said earlier in this class, that storage variables cost more gas fees than other type of variables, other s- storage formats. Okay, now we have the storage, we have the memory. All right, memory is lighter than storage. Okay, and we know that these guys, when you put it here, you are telling Solidity that these guys are stored and you are going to be reusing them again. All right, these guys are stored and you are going to be reusing them again. So they are not stored temporarily, they are stored permanently. So whenever you are running the contract, space is used as well. Okay, and gas cost gas to run these guys. Okay, so it would have been even more if these guys are public. All right, if these guys are public, it would have been more, because public variables will be run. You understand? The contract is going to be working on them, but private variables, they are hidden. All right, so they don't use them until they are called. Yeah, that's private variables. For public, they are always in use. Whenever you do call the contracts, they are upfront because they are public variables. They are always ready to be used altogether. So these are gas costs. This how much our, our test is is costing us. Okay, so there are ways to optimize your code in a way that you can limit gas. You can limit gas, especially when you are withdrawing. Okay, there's a way you can limit gas, especially when you are withdrawing. All right, but first of all, let us see, can we add gas our to our to our tests, so that when we run our tests run in a way that is simulated, in a way that it can it adds gas to the transaction. All right, right now it doesn't add gas to the transaction. Gas is zero. All right, gas is zero. So it doesn't add gas, but we can do it in a way that we can add gas for the transaction. Okay, so how do we do that? How do we simulate gas for a transaction? All right, so let us go back to our contracts. All right, let's go back to our single contracts, our single funders contracts, withdrawal contracts. All right, so let's use this guy because there is this guy. Okay, so we can come here and say that let's create a simulated gas here. Yeah. Okay, so let's call this guy gas. All right, so we're going to make this guy constant because we want it to constant. Okay, you can give it anything. Let's just give it one. All right, so our gas is going to be 1. All right, so we can come back and all right, so let's look for single withdrawal. Okay, so you can say that the 256 gas starts. All right, so gas starts is going to be equal to um, gas left. All right, so let's just do it like this. All right, what is that? All right, so let's. Okay, so we can come here and say VM dot gas transaction gas price. All right, so okay, so we can continue and say that after withdraw. Okay, so after withdraw, you can say that. Sorry, let's just run it. Whatever error we got, we fix it. 256. That's 8. That's okay. So okay, so we can say that units 256 and 256 gas used is equal to gas left. Um, okay, so we can do it this way. gas stats minus gas end multiply by TS gas price. So can console.log so that we can see our outcome. Okay, so let's all right. So all right, let's fix our errors. Okay, so here do we have errors from? Okay, so let me see, then Frank. Okay, here, here. Okay, so starts. Okay, so let me fix this. I think that's this. So am I getting it wrong? Okay, so am I getting it wrong? Okay, so on the 25. Alright, so supposed to have this. Supposed to be TRS. Alright, okay, on the 25. 35. Okay. Okay. All right. Let me just go through it again and let me see where I'm missing it. I know I'm missing something. So let me just go through it again and see. Okay. So let me see if I can copy this and let's see here. Okay, vm.tx. This supposed to have search this guy. Okay. All right, so I'm running into unprecedented error. Okay, let me see. Okay. All right, so I'm going to look at it because of our time. I have limited time. So because of our time, I won't have to go into trying to debug this right now. And okay, so but in case you run into any error, you can always prompt your AI to actually fix this. But won't be fixing this right now. Okay, so we'll just move on. But if you want to get more about your gas, all right, you can use the forge snapshots for it. Okay, so I'm going to revisit this. All right, so I think I will address this in one of our unofficial classes. Okay, in one of our unofficial classes, I'm going to address this. All right, but for now, let me just comment my guys out for now. All right, something is missing, but I don't have the time to look at it right now. I still have other things to show us. Okay, so let me just go to guys. Okay, so um, all right, so we can come and forge tests. All right, let me just test if we are back on track. Okay, so we are back on track. Okay, so because of time, I'm going to be jumping over other things. All right, but I'm going to be dropping us a resource, okay, in the group for further studies, all right, and for more clarity. Okay, so now if you notice throughout the course, I've not used a .env file, okay, and then we're going to be using .env file today. All right, reason because okay, so we have sepolar URL. I have, you saw how I got how we all know how to get a sepolar URL. Go to our Alchemy, all right, run a node, all right, create app. We've done it several times, and also private key. Okay, so this is one of our Sepolia's private key. It is not advisable to publicly put your private key, store your private key in .env file. Okay, reason because that once it's added, it can be compromised. All right, and also ensure that whenever you are using .env, your .env is included in your git ignore, so that when you are pushing to your GitHub, it's not included in your GitHub. Okay, so when you are pushing to your GitHub, it's not included in your GitHub so that somebody will not access it, will not have access to it. All right, so that it will not be pushed there. Okay, so back to our .env file. All right, now we're going to be using something that we've not talked about, we've not mentioned ever before. Now it's going to be a makefile. Makefile, let me spell it. Makefile is um makefile. All right, so makefile helps us to, in summary, you can always use ChatGPT or YouTube, or there are courses out there that talks about makefile. I can't go into makefile now, all right, but I can give you a hint on how to use it and how to install it. All right, so you can install it through websites, you can install it through command prompt, command line. All right, so I will always recommend you use the command line because it's very easy. All right, just get the command and go to your command prompt. Make sure you run your command prompt as an administrator, and then run the code. And in few seconds, you've installed Makefile in your system. After installing Makefile in your system, you can come to your extension. All right, search for Makefile. So you get the extension. All right, Makefile 2, and then you install it. Okay, you can install it. Right, this one I'm using. All right, so you can install it. So after installing it, all right, you can come to um create a new file, and then make file. All right, so if you have any issue installing makefile, you can always ask questions, okay, to help. All right, you can always ask questions to help. Okay, so um why do we use makefile? Why do we use makefile? So we can include um okay, so we can include .env so that we do it like this. .env, okay, so that we can include every of our stuff that we've added here. We can add it here. Now, okay, if we want to deploy our contract, let's say we want to deploy our contract to um Sepolia. Let's say we want to deploy our contract to Sepolia. All right, we want to test our contract, to deploy our contract to Sepolia. Normally, we write the forge script, um, scripts, what else? Slash deploy on me. Oh, sorry, on me. Dot s dot so. Okay, and deploy funny, and then we get our RPC URL. All right, so I'm going to get our RPC URL. We're going to be using we're going to be using from our .env. All right, so we don't need to copy and paste this guy again. You can just get a dollar sign. Okay, so we are here. So a dollar sign and then Sepolia. Sepolia RPC URL. Okay, so this one suffice for this long, so you don't have to write all this long stuff again. So you just write down. Okay, and then private key. Okay, so we put our private key. Like I said, this is unprofessional. Okay, so you should never do this. You should never do this. All right, and then our broadcast. Okay, and then we want to verify this. Remember the last time I told us that we manually verify our contract on Etherscan. Okay, so what you do is that you go to Etherscan, you create a new file, sorry, new account. You create an account with them. If you have an account already, no problem. You create an account. You go to accounts. All right, go to accounts where you have your username at your top right, and click on it. You are going to see API. You're going to see API, and then you see at the button creating API. Let me see if I can show us. Let me see if I can show us. Okay, so just give me a few seconds. Let me. I really don't want to delete this class because opening these guys will my network is really dull, really dull, really dull. Okay, so I'm trying to load it. All right, so my network is really dull, really dull, really dull. Okay, all right, I'm coming. Let me let me log in. Okay, so let me just share my screen. So I'm coming. Let me share my screen. I'm almost done. Sorry about this um blackout. Sorry about that. Okay, so taking time to share my screen. I don't know why. Okay, so let me share everything. All right, so if we come to accounts, all right, after now, okay, this is my account. I have created an account with Etherscan, all right, Etherscan. So you come to your name is your profile, all right, and then you come to API keys. Okay, API keys. You select API keys, okay, and then you come to a place like this, all right, and then you click select like new add, sorry, this plus add here, all right, click on add, all right, project name, so let's call it Sepolia Fund Me, all right, and then create a new key. Okay, when you create a new key will be given to you. Just copy this, okay, come to your .env file. So I'm going to swap this with this, okay. So I'm going to swap this with that and save it so that in my verify, all right, I can come here and say Etherscan dot API hash key. Okay, so I'm going to be calling our guy here, the Sepolia guy. So going to be am I spelling this correctly? No, scan API key. Okay, so and then we can v. All right, now if you want to run this, now you see how long this guy is. All right, let me copy this guy. All right, sorry. So let me copy this guy. Now you see how long my command this thing is. Let me delete. Okay, so you see how long this guy is, all right, how long it is. Now instead of me to write this guy over and over and over again, that means anytime I want to run this deployment, anytime I want to deploy this contract like this, I have to type in this plenty code. All right, so how do I save myself the stress of typing this plenty code over and over and over again? That is where this makefile comes in. All right, so let's take for example, okay, so let's take for example, let's say we we we'll say build. Let me copy this guy. Okay, I want to copy this guy so we don't have to suffer ourselves. And I just hope I copied it. Okay, let me see if I copied it. Okay, perfect. Okay, so let's say we say build, and then we want to test how makefile works. Okay, we say forge build. All right, so if I save this and I come to this place and say um, make build, it's going to run forge build for me. Okay, so instead of running um, make forge build, I have encoded it in a way that I will not be writing forge build, I'll be writing just build. Okay, so we have be writing make build. All right. Okay, so let's do it with a bigger function. Okay, let's do it with a bigger function. Okay, let's say we call this guy deploy sepolia. All right, so you can um enter and then tap. Okay, so this one, okay, let me just enter. All right, and then let me break it here so that we can see the rest of the code. Okay, so um so if you don't want to write it like this, if you want to, you can write it like this, or you can write it like this. Put your enter and then hyphen. Okay, make sure there's no space here, so tab. All right, so either you write it like this or you write it like this. Okay, sorry, like this. All right, so it's either you write it in one line or you remove this semicolon, press enter, and then tab to shift it like this. Okay, so run it like this. Okay, so I haven't done this. It's very long, so we have to put these guys in brackets. Okay, so put these guys in brackets. Okay, so I'm going to on my word toggle. Okay, so that word wrap. Sorry, I'm going to toggle my word wrap so that this guy is going to work well. Okay, so instead of me to write all these guys, I can just come here and say make deploy sepolia. All right, and so this guy is going to run. Okay, so instead of me to run all this guy, I'll just run this guy, and boom, I've been able to deploy my contracts. Okay, so I've been able to deploy my contracts and deploy it to the sepolia ETH network. All right, I've been able deploy my contract and deploy it to Sequoia 8 network. Okay, so if you have any question to what we've done so far, all right, you can always drop the question. There are some certain things that I skipped, okay, just to meet with time, all right. There are certain things I skipped just to meet with time, okay. So let me just lastly before we go, let me introduce us to Git, okay. So let me introduce us to Git, and then I'll just introduce us to Git. I'm going to be dropping a tutorial on how to work with Git, okay? How to work with Git, how to push Git, how to and all that and all that and all that. But for now, let me introduce you to Git. Okay, so let me open my Git. Um, sorry. All right, so um, okay, um, let me let me sort myself with my Git. Yes. Okay, so just give me a few seconds. Let me. Okay, so please just wait. Let me verify my Git. Let me let me just sort my Git out. Okay. Okay, so earlier today I had issue with password, so I needed to sort myself out for the class, but I couldn't. Okay, so just give me a few minutes. I'm still on it. I'm almost done. All right. Yeah, you. Okay, so just want to show us something. They just give me a few seconds. Okay, so let me share my screen so that you can see what I'm doing. My screen. Now, if you can see, you can see that this is a very empty repo. Okay, so I created this repo for this class. All right, so this is a very empty repo, right? This is a GitHub account. If I say empty repo, sorry, empty GitHub accounts. All right, so if you open your GitHub account for the first time, this is how it's going to look like. Okay, so you see this green button here, new. All right, this to open a new GitHub repo. All right, if you come here, you see home, issues, pull requests, projects, discussions, code space, copilot, and all that. If you come to this side, you're going to see profile, your repositories, your repo, GitHub pilot, projects, and all that, 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 and all that. All right, so let's say you click on this new to create a new repo, right? You can call this repo Foundry. Okay, you call this repo Fund Me Foundry. All right, so after naming, giving it a name. All right, so we have public and we have private. All right, if you put it in public, that means it's open source. Everybody can see it. Everybody that have access to your Git can see it. All right, so if you send your GitHub link to somebody, the person can see it. All right, and then private, that means nobody can see it. All right, so whatever code you want to use for your resume, whatever code you want to use to get a job, should be public. Else, when it's private, nobody is going to see your code. All right, and then we create repository. So when we create repository, this is how your repo is going to look like. Okay, this is how your repo is going to look like, and then you follow these commands to push your Git, your code to your repository. All right. Follow this command to push your code to your repository, and then because of time, we can't go through that particular process right now. But if you have any challenge pushing your code to repository, to your to a repo, drop it in the comment section. Drop it. So I say drop it in the comment section. Drop it in the group chat. Drop it in your group, your WhatsApp group, in your WhatsApp group. Or drop it in the Telegram group. It will be fixed as soon as possible. Whatever is inconclusive in this particular class will be fixed as you drop your questions. Once you drop your questions and say, "I'm finding it difficult to push through the repo. I find it difficult to push. I follow the steps, and I'm having difficulty." Drop it, and I will attend to it as soon as possible. All right, I'll attend to it as soon as possible. All right. So if you look at it, we've learned how to push. Oh, sorry. We've learned how to use .env, okay, to create .env, and how to use .env. We've also learned how to use makefile. All right, so there are other configurations, there are other uses of makefiles that makes your programming easier. All right, so if you want to learn more, there are resources out there. Okay, so I'm going to give us a resource that will also help us to further uh, our learning curve as a blockchain developer. Remember, this course is just introducing us to blockchain development. Okay, I believe we that have been taking this course that have come this far, we are determined to be blockchain developers. Okay, so I'm also determined to help you down the way. All right. But congratulations if you have come this far. Congratulations if you are seeing this. Congratulations if you're in class. Congratulations if you are watching this. Okay. If you have come this far. All right. And little or nothing can stop you from advancing. All right. And for courtesy's sake, okay, this course, the textbook for this course is Cypher of Craft. All right, I find it one of the most complete um, resource for blockchain development. One of the most resource for blockchain development. Okay, and that's run by my boss Patrick. All right. Okay, so I'll also send us the link. I'll send us so that we can further our learning and will not be limited to this. All right, like I said, that program is the textbook for this course. I see that. Okay, so I like the approach, and I borrowed the approach. Very, 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 very. While building projects, you're learning a lot. While building projects, you're learning a lot. For you to know, you have to build project as many projects as you can build, whether small or big. Build projects, make mistakes, fail, and learn. All right, and that will be it. Write your questions, write your concerns, everything you want to write. Push them to our Telegram group. I will be attending to us, all right? But today is our last day officially having class, all right? So I want to really appreciate all my students. I want to really appreciate everybody that have come this far, that have battled to have gotten to this level. I want to say thank you very much. Thank you for your faith. Thank you for pushing. Thank you for believing in yourself. Thank you for not giving up. Thank you for not falling out of the way. I really appreciate all of you. I really appreciate Tifem for giving us the opportunity to meet and learn and to learn together. All right. I I want to thank Tifem for that, and I believe you are that out of gratitude as well. All right, so thank you very much for coming this far. Like I said, if you have any question at all, please do well to reach out to me. Drop it to the Telegram group, drop to your group chats, your different group chats as well. Look forward to your exam on Monday. I'm also looking forward to your project in January. Thank you very much. I really appreciate. I really really appreciate. Thank you very very much. Do have a good night and do enjoy yourself. I remain Mr. Sam, and it's been a beautiful journey with you. Thank you very much. Thank you. Thank you. Thank you. Thank you. Bye bye.